Okay, so this is our second day of solving rationals, so these are going to get a little bit more intense. So to solve a rational equation, solving for the variable, you first need to eliminate the denominator. This can be done by identifying the LCD, multiplying each and every term on both sides by the LCD, simplifying, solving the resulting equation, check for non-permissibles, and then you need to check by subbing it back into the original. So what is my LCD here? That would be x minus 1. Everybody knows that the 3 has a denominator of 1, and 1 times anything will just be that. So x minus 1 is the LCD. So we're going to multiply each and every term by that. So I didn't give my enough space here, so I'm going to actually write it out with a space between. Okay, the next thing is make sure you do the non-permissibles. So the NPVs are x cannot equal positive 1. Okay, so my LCD is x minus 1, so I'm going to multiply each and every term by x minus 1. I'm going to do it in a different color. So I'm going to show that I'm multiplying each and every term. Remember, Algebra 101 says whatever you do to one side, you got to do to all the sides. So does everybody see this x minus 1 will cancel this x minus 1, and this x minus 1 will cancel this x minus 1. So then what am I left with here? I'm left with 2 plus 3 times x minus 1 will be 3x minus 3 equals 4. So I'm going to move it over. What's 2 minus 3? Minus 1. If I move it over, I get 5 on the other side. So x equals 5 over 3. And then you got to make sure that this works. 5 over 3 is a little bit harder one to check. That's okay, we can still check. So check 2 over 5 over 3 minus 1 plus 3. This is my left side. So 5 over 3 minus 1, well 1 is 3 over 3. So this is 2 divided by, what's 5 over 3 minus 3 over 3? Well, that's 2 over 3. So plus 3, of course. So if I flip this, I actually get 3 plus 3 plus, which is 6. So my right-hand side is 4 over 5 over 3 minus 1. So I get 4 over, again, this is 3 over 3. So this is 2 over 3. And so when I flip that, I'll show my flip this time because you probably didn't know what I did in the last one. So 4 times 3 over 2. You see the 2 goes into the 4 twice, and I get 6. So it checks. All right, next one. What's my LCD here? Well, my LCD is going to be 2 times x minus 7. So again, I'm going to give myself some room here. 2x minus 9 over x minus 7 plus, oops, I'm not getting myself enough room, plus x over 2 equals 5 over x minus 7. So I'm going to multiply each and every term by 2 over 2 times x minus 7. 2 times x minus 7. 2 times x minus 7. So x minus 7's cancel. The 2's cancel. The x minus 7's cancel. Oh, I forgot to do my non-permissible. Does everybody understand that 2 does not contribute to a non-permissible? 2 is 2 no matter what. It's never going to be 0. However, x minus 7, if x was 7, that would give me a 0 at the bottom. So my non-permissible values is x cannot be positive 7. So once I've canceled, I have 2 times 2x minus 9, so I get 4x minus 18. And here I get x times x minus 7, so that is x squared minus 7x. And here the x minus 7 cancels, so I just get 10 out of it. So we have a quadratic. How do we solve a quadratic? Get everything over to one side, and hopefully it factors. So x squared minus 3x, if I move the 10 over, I get minus 28 equals 0. So that factors to be x minus 7, x plus 4, which means x equals 7 and negative 4. Everybody notice that I have a non-permissible there. It can't be 7, so I need to reject it. So I reject 7 because it's a non-permissible. Let's do my check just to make sure I get 100% on my quiz and my test. I'm going to substitute negative 4 in. So I'm going to check my left side. 2 times negative 4 is negative 8. Minus 9 is negative 17 over. Negative 4 subtract 7 is negative 11. Plus negative 4 over 2. Ooh, how do we do fractions? Well, we got to get a common denominator. So that's 22. So we're going to get 22. So this is going to be 2 times that. A negative divided by a negative is a positive. So I'm just going to simplify that at the same time. So 2 times 17 is 34. And then plus a minus is just a minus. And then I got to multiply that by 11. So minus 44 gives me what? Negative 10 over 22. And I can reduce that, but honestly, I don't need to know that because because in a second I'm going to see if I get the same answer. So negative 4 subtract 7 is 5 over negative 11. So maybe I should reduce this one back up here and I get negative 5 over 11. So they check. Moving on. If I factor this, I get x minus 2, x plus 3. So what's my LCD? It would be x minus 2 times x plus 3. So at this point, if you understand that things are going to cancel when you multiply each and every term by it, you can skip the step where you're showing multiplying both sides by x minus 2, x plus 3. So that's what I'm going to do here. If you don't understand, you might want to show that step. So if I multiply 2 over x minus 3, x plus 3 by x minus 2, x minus 3, does everybody see the denominator cancel? And I'm just left with a 2 plus 1. Now I'm multiplying by x minus 2 times x plus 3, and the x minus 2's will cancel, so then I'm only going to be multiplying by x plus 3 equals 3. Again, I'm multiplying by x minus 2 times x plus 3. So that means the x plus 3's will cancel, and I'm only left with x minus 2. So I'm going to simplify all this. 2 plus x plus 3 equals 3x minus 6. Let's move all the x's over. So I get minus 2x. This is 2 plus 3 is 5. I move it over, I get negative 11. So I get x equals 11 over 2. I forgot to do my non-permissible, so let's do that right now. So x cannot equal, the denominator is x minus 2 and x plus 3, so that would be 2 and negative 3. And of course, the 11 over 2 is not one of those, so it looks legit for right now. And of course, you should be checking it to make sure you get 100% on your test if time permits. So, next one. If I factor this one, I get x minus 1 times x plus 1. So my LCD is x minus 1 times x plus 1, which means my non-permissible values is x cannot equal plus or minus 1. So I'm going to multiply each and every term by x minus 1 times x plus 1. So I get 1 times x minus 1 plus 1 times x plus 1 equals 2 times, well, they all cancel, so it just equals to 2. So I get x minus 1 plus x plus 1 equals 2. So I get 2x, the 1's cancel, equals 2. So x equals 1. Except that was one of my non-permissibles, so now I need to reject it. Since I have no other choices for solution after I rejected, that means there is no solution. Okay, next one. If I factor b, I get x bracket x plus 2. So my LCD is x times x plus 2, which means my non-permissible values. I highly recommend after you find your LCDs to go automatically to your non-permissible so you don't forget. So in this first factor, x can't be 0. And the second factor, x can't be negative 2. So I'm going to multiply each and every term by x times x plus 2. In the first one, 1 over x, the x's cancel, and I'm left with x plus 2. In the second one, I have x minus 1, but the denominator is the LCD, so that means they all cancel. I'm just left with x minus 1. And then I'm left with negative x times the x plus 2's will cancel, and then I have to multiply it by an additional x. So I get x plus 2 plus x minus 1 equals negative x squared. Move everything over. I get x squared plus 2x plus 1 equals 0. So if I factor that, I get x plus 1, the whole thing squared equals 0, which means x equals negative 1. And that looks good for solutions, and you should check your answer if time permits to make sure you get 100%. Our last example is this one here. So I have a 2x, I have an x times an x plus 6 on the bottom, and I have a 2 and an x plus 6. So my LCD looks to be 2x times x plus 6. So I'll let you think about that for a second to make sure you understand that the LCD is 2x times x plus 6. So if I multiply the first one, 1 over 2x, I might show my steps for this one just so you can see. So 1 over 2x, and then I'm going to times this by 2x times x plus 6, minus 9 over x times x plus 6, and then that's getting multiplied by 2x times x plus 6 equals 2 minus x over 2 bracket x plus 6, and then that's getting multiplied by 2x x plus 6. So the reason I'm showing my steps is just in case this one's a little bit more complicated of an LCD. So the 2 will cancel and the x will cancel. Here, the x will cancel and the x plus 6 will cancel. Here, the 2 will cancel and the x plus 6 will cancel. Okay, so let's multiply this out. I have 1 times, the only thing left here is x plus 6, so I just get x plus 6. Now watch, this is a minus with a 9 here. So it looks like everything canceled except for this 2 here. So minus 9 times 2 is minus 18 equals. It looks like everything cancels except for this x, so I have to multiply the x times 2 minus x, so I get 2x minus x squared. I'm going to move everything over to the left side, so I get x squared minus x, and then 6 minus 18 is minus 12 equals 0. So I get x minus 4 times x plus 3 equals 0, which means x equals 4 and negative 3. I forgot to do my non-permissibles. Let's do that right now. I'll do it over here. Non-permissible values. 2 will never equal 0, so I don't have to worry about that. Well, x can't equal 0. And x plus 6, that means negative 6 can't equal 0. So it looks like both of these will work. And of course, if you have time, check your answer. All right, let's continue. What's my LCD here? My LCD would be 3x minus 1 times x minus 4. Just so you know, if you have a fraction equal to a fraction, you can actually do a cross multiply. So I'm going to show this method, this 2 different ways. So method 1 is our usual method where we multiply each and every term by the LCD. So that means it's going to be x minus 5 times x minus 4 equals On this, the right side, I get x plus 5, and the x minus 4s will cancel, so that has to be multiplied by 3x minus 1. So this is the LCD one. Method 2 is when you have a over b equals c over d, you can cross multiply. Do you see if I cross multiply here, I get exactly the same thing that I do what I just wrote. So here's where people will make a mistake, is they forget they need to FOIL. So first we get x squared. Outer I get minus 4x, inner I get minus 5x, so minus 9x plus 20. On the right side there's a FOIL as well. X times 3x is 3x squared. Outer gives me minus x, inner gives me plus 15x, so that would be a plus 14x. And then last I get minus 5. So I move everything over to one side. 0 equals 2x squared plus 23x, and then what? Minus 25. So hopefully it's factors. I'm thinking 2x and x, and it looks like a 25 and a 1. Yes? So I need a plus 25 and a minus. So that means x equals negative 25 over 2 and positive 1. I forgot to put what my NPVs are again. X cannot equal positive 1/3 and positive 4. And that is not one of them. So there we go. So for h here, we can't do a cross multiply. We have to do multiply each and every term by the LCD. So what's my LCD? My LCD is x minus 2 times x plus 3. Sorry, x plus 2. So I'm going to multiply each and every term by that. So I have 3 minus x. The x minus 2's cancel, so I have x plus 2 equals, well, 1 doesn't have a, well, I guess you could say 1 has a denominator of 1, but it's not going to cancel anything, so I'm going to have x minus 2 times x plus 2 times the 1. I don't need the 1 there, but I'm going to put it anyways. So then I have, now here's the thing. Remember what I said about a subtraction? What I would do is I would put a plus and then change this into minus 2x plus 5. And the x plus 2 cancels with the x plus 2, so now I'm going to be multiplying by x minus 2. It's just way easier to not make a mistake with signs. So first I get 3x, outer I get plus 6, inner I get minus x squared, and last I get minus 2x. Next one, if I FOIL that, the outer and the inner cancel, I'm left with x squared minus 4. With this one, I get minus 2x squared. Outer, I get plus 4x. Inner, I get plus 5x. And last, I get minus 10. Alrighty, so I need to move everything over to the other side. So it looks like when I move the x squares over to the right side, I get them all to cancel. That's kind of nice. So 3x minus 2x is 1x. If I move that over to the other side, I would get 8x. And then when I move the 6 over, minus 4 minus 10 is minus 14 and minus 20. So that would equal 0. Let's just check this again. So minus x squared goes over. I have a 2x squared and a minus 2x squared. That cancels. 3x minus 2x is 1x. Move it over. I have a minus x, which will cancel one of the 4x's, and we get an 8x, and then the 6 comes over as a minus 6, minus 4, minus 6. Okay, so everything's good. So I get 20 equals 8x, so x equals 20 over 8, which reduces to, well, 4 goes into both, so 5 over 2. I didn't do my non-permissibles again. My non-permissible values, of course, are x cannot equal positive 2 and minus 2, which isn't 1. And again, I should check if I have time. Okay, this one's even more crazy. What is my LCD? Looks like it's x minus 3 times x plus 2. Let's do my non-permissible values right away. X cannot equal 3 and minus 2. Okay, let's go. 3 times x minus 3, because the x plus 2's cancel. Plus 1. Well, the denominator was 1, so nothing cancels. So it's going to be x squared minus x minus 6. I'm using the multiplied version of it because that's just easier in the end. So then I have a 3x, and if I multiply by the denominator, they all cancel. And then I have a minus 5 times x minus 3's will cancel, so I have x plus 2. So I get 3x minus 9 plus x squared minus x minus 6 equals 3x minus 5x minus 10. I think I'm going to simplify, well, I can move things over, I guess. I'm going to move everything over to the left side because that's where I have a positive x squared. So x squared, 3x minus x is 2x, and on this side I have a 3x minus 5x, which is a minus 2x. If I go over there, it'll be a plus 4x. And then a minus 9 minus 6 is minus 15. And if I add 5, it would be minus 5. So what do I get? X plus 5 times x minus 1 equals 0. So x equals negative 5 and positive 1. And that looks legit. So there we go.